What a nice sunny day today. And speaking of the sun, the Parker Solar Probe is going to dive closer and learn more about the sun than ever before. In this video, we're going to learn about this mission and talk about how engineers at NASA and the Applied Physics Lab were able to design a spacecraft that could reach over 1300 degrees Celsius in the blistering heat of our home star. Perhaps Parker Solar Probe will teach us something new about our soul. The Parker Solar Probe was named after Eugene Parker. It's actually the first probe named after someone while they were still alive. Eugene Parker is an important astrophysicist that helped us understand more about our place in space. Thank you, Eugene. This mission is designed to get closer to the sun than any spacecraft has ever been. One of the main science goals of the probe is to measure electromagnetic fields with a flux gate magnetometer. That sounds like a science fiction weapon. The sun not only emits lots of radiation, it also constantly emits charged particles, including protons and electrons. Parker will take a tiny scoop of the stellar dust to learn more about the things that our sun may be throwing at us. Instruments that stick out past the edge of the heat shield can measure velocity, density, and temperature of those charged particles. And who could forget the cameras on board that will surely provide some breathtaking views of the stellar corona. For some perspective, if we shrunk the space between the sun and the Earth down to a football field, the Parker Solar Probe would reach as close as the 4-yard line. That is quite close on our cosmic ruler. So, how is the spacecraft supposed to stay cool? The sun is like really hot, so where does all that heat go? Well, it turns out NASA is no stranger to high temperatures. Did you know that the space shuttle could get as hot as 1600 degrees Celsius during atmospheric entry? That's 300 degrees hotter than the expected temperature of the Parker Solar Probe. The heat shield on the underside of the space shuttle was very specially designed to ablate this heat, or warm up material to absorb heat and then shed it off so the next layer can do the same. This could work for the Parker Solar Probe, but it is going to be near the sun for years of time. What happens when all that ablative material is gone? Well, that's the end of the mission. The real difference here has to do with the vacuum of space. On Earth, when we cook food in an oven, we usually warm up the air around it, and then that heat will slowly transfer to the inside. In space, there is no air, so the probe doesn't have to worry about being warm in every direction around it, but just the direction of the sun. Have you ever broiled your food? Broiling is different than baking. A broiler will radiate infrared heat down on the food cooking from one side. It's pretty similar to our mission. As the sun tries to broil the probe, a layer of carbon-carbon insulation absorbs the heat and slowly dissipates it in other directions. So, as the sun broils our probe will then re-radiate that heat out as infrared in every other direction. So, in a sense, the Parker Solar Probe will be a tiny little broiler itself. In order to keep electronics and solar panels cool, we have to use something called liquid cooling. Your car and some modern computers use liquid cooling to transfer heat to the right places. By circulating water, that's the same liquid you drink. Through hot parts of the spacecraft to cold parts of the spacecraft, we can effectively keep the temperature stable when we need it. Solar panels need to be somewhat cold to operate, so this liquid cooling is pretty important for the probe's survival. This mission will, of course, provide us with more information about our very own cosmic campfire. Without the sun, no life would walk the Earth. The incredible part is, it turns out that the sun is just another star. Many other stars throughout our galaxy are not too different from the sun. So the knowledge that the Parker Solar Probe provides about our solar system will be used to know more about stars across the universe. That should shed some light on our cosmic perspective. I hope you are as charged as I am for this mission. Scientific results may be a hot topic one day soon. Drop a comment below if you're excited for the mission. Parker's launching on a Delta IV Heavy, which is a very powerful rocket. It's always thrilling to see another launch by them. I do hope you learned something from watching this video. Be sure to subscribe if you'd like to see more. For now, have a sunny day. And remember, be curious.